Here is the outline of my paper. Well, the subject first is the relation between feelings of effort and feelings of confidence in cognitive agency. Introduction will be about what is cognitive agency and what metacognitive feelings are. Second, the question of the informational source of metacognitive feelings. Is it effort or is it performance? Then, well, of course, to substantiate the question, I need to have first made the introduction. And then we'll compare the predictions from the two main competing views about the source of metacognitive feelings, and then I will come up with a conclusion. Okay, introduction. Well, to define action, I will start with Harry Frankfurt's definition. Of course, I cannot defend it right here because I have many other things to do, but I think it's a useful start. Behavior is purposive when its course is subject to adjustments which compensate for the effects of forces which would otherwise interfere with the course of behavior. So this notion of behavior does not suppose a separate moment for intending to act. It just presupposes that there is a goal and there is regulation towards the goal. From this definition of action, we can go up to the definition of a cognitive action. A cognitive action consists in using compensatory mechanisms to maintain a trajectory toward a cognitive goal. The examples of cognitive actions have already been given, but just to give you a new idea of this: controlled perception, like trying to discriminate, to categorize; controlled memory, like trying to remember, to learn; controlled reasoning, like trying to solve a problem, to understand an argument, to plan; communicating, like trying to persuade; and also controlled imagination, trying to invent, trying to extend one's thinking. Of course, the trying here is here to remind you that there are lots of things we do without trying because they are just performed associatively, like perception can be automatic, memory can be automatic, reasoning automatic, and so on. And this does not belong to the realm of cognitive agency, at least in the proposed definition. So an additional view that has been widely defended in the literature is that action feedback, that is feelings, track discrepancies from an expected trajectory. So the idea is that acting cognitively does not require permanently controlling our train of thoughts, but being prepared to repair it if necessary, that is when a discrepancy is detected. So this leads us to hypothesizing this kind of mechanism that is called a comparator. At each point of an epistemic evaluation, a comparator must step in, having the following structure. What is compared is expected and observed feedback. And these types of feedback have been stored from past mental activity. And what is stored is a norm of good functioning for that comparator. And there is also now neuroscientific evidence that such comparators do exist. And there was already a description by Chandra of the draft models that exist for these kinds of heuristics. So this left part of the comparator is non-conscious, but the right part is, that is the output of the comparator is a metacognitive feeling that is indexed on the task. It has a valence that is more or less positive and an intensity that is more or less positive, well, high. And those together, valence and intensity, plus also the associations of the context lead to a decision, a cognitive decision. Well, just to give you an idea of how these cognitive actions take place every day, well, they are generally embedded in instrumental actions. So the nice thing is that although instrumental actions have a norm of utility, cognitive actions have a norm that is first directly an epistemic norm. That is, they must be correct for the encompassing action be successful. If I have a shopping list to reconstruct, because I forgot it at home, for example, well, better remember correctly the items on the list, otherwise my supper will not be the one I intended it to be. Okay, so now the important things are here, the little reflexive arrows here. And the blue arrows refer to evaluations for the instrumental action to take place. First, to start the action, is that the kind of action I need to do? And then there are plenty of other little blue arrows that detect possible discrepancies between what is expected and what is being found. And then finally, there is a final evaluation whether the action is well performed. But what I am interested in is the central section, the section where the cognitive action takes place. And here too, we have a lot of reflexive arrows. This first one determines whether the goal, well, first, which goal is necessary at the point of time where I am in the instrumental action. For example, my goal is to reconstruct the list. Is it feasible? And then while you go on with your action, there are more arrows. Each time an error signal comes up, you need to see how to repair it. And at the end, there is also a norm that evaluates the result of your action. Is the result I'm coming up with, is it correct, or is it likely incorrect? So here is the kind of things that we need to do all the time when we act. We need to evaluate whether in the physical instrumental world or in the epistemic world. So, but the great question is, what is the informational source of metacognitive feelings? There is an important controversy in the literature. Sorry, I tried to get rid of this little part of the vignette that masks my own screen. An important controversy in metacognitive studies is, what are the informational sources that drive cognitive decision making? That is the informational sources of the feelings. What is the feedback used by the comparators on which evaluations and predictions depend? So if we come back here, the important point is this. What is the expected feedback and the observed feedback? What are the stored heuristics that are being used and that decide how decision making, well, they just influence decision making for or against a given task or a given revision or a given evaluation. To address this question, there was an analogy that has played an immense role in the literature, and it dates back to 2006, although the original notion of the bear and the hiker, comes back to William James times and the James Lang theory. But this analogy has been used by Ashok Coriat, Hilit Mayan, and Ravit Nasinson for a tremendous piece of literature. And I invite everyone interested in effort in reading that piece. So let's imagine a hiker encountering a bear. Now, let's suppose that the hiker runs away, because I've heard that it may not be the best strategy when you when you encounter a bear, but let's imagine that the hiker's strategy. Does the hiker run away from the bear because he or she is afraid? In this case, the faster he runs, the safer he feels, then the less afraid he is, okay? And this is called performance feedback. His own performance sends in a message to the comparator, well, you know, the distance I have with the bear is increasing, therefore I'm on the safe side. But there is an alternative idea. That is James' notion of emotion. Maybe the hiker is afraid because he runs away. And in this case, the faster he runs, the more afraid he is. The authors call it the data-driven feedback from control, and I agree that it's really not a very easy way of characterizing facts. But keep in mind that it's the effort that is expended in running that causes fright and not vice versa. So now let's apply this to a cognitive action. How is the judgment of learning formed when we are learning? Is the agent's metacognitive prediction driven by a noetic feeling triggered by observed performance? In this case, for example, in the case of a judgment of learning, the activity consists in learning. In that case, the more time one spends studying an item, the more confident one should be to have learned it. So that's the performance feedback view. Or in the alternative theory, maybe the agent's metacognitive prediction, his judgment of learning, is driven by the sensed effort invested in the activity, just as in the case of the bear, is running fast that was creating the feeling of fright. Maybe here is the more effortful task, the more effortful a task feels, the less likely it seems to be correctly performed. So it's called data, by the authors, data-driven feedback from control operations. So Coriat and colleagues respond to the proposal 1. That is the view that one's perception of the effort invested in an activity should increase one's confidence in learning or in problem solving or any other cognitive activity. They respond that this view is backed up by a naive belief about one's own cognitive functioning, but that things are actually much more complicated. As they say in their title, the relationships between monitoring and control are intricate. But as I will attempt to show, their proposal is much more compatible with evidence. So let's compare predictions from views 1 and 2. First, let's see what is the experimental task. This experimental task is a very big one. It includes seven subtasks. It's designed to test the basic hypotheses of view 2, which they call the monitoring model of memorizing effort, which again is not excellent as a mind catcher. But here are the two views that this theory 2 wants to defend. Learners indeed use their memorizing effort, which actually they take to be captured by study time, as a predictive cue for learning. And the judgments of learning that are provided at the end of the study are inversely related to study time. That is, indeed, as they predict, the more you try, the less likely it is, subjectively, that I will perform well. And the second hypothesis is that indeed this is correct. That is, memorizing effort is a valid predictor of long-term recall. The study time is inversely correlated with recall. So let's try to see how this works. Well, if we take the classical view, the discrepancy reduction model that has been, for example, presented by Dunlosky and Herzog in 1998, the reasoning is the following. Because study time, that is subjective effort, is determined by the perceived discrepancy between observed learning and the stored learning norm during performance, judgments of learnings should increase with study time. You should be persuaded to be better at remembering the longer you have decided to spend on a given piece of to remember. And second, memorizing effort should be a valid predictor of long-term recall. That study time should be directly correlated with recall. So now, what is exactly the memory task that is given? The participants have to study 60 Hebrew word pairs with different associative strengths, that is more or less difficult to memorize. So in certain conditions, they can use as much time as they want. In others, they can't. In all cases, they produce a judgment of learning after having learned a given pair. And this judgment of learning is requested in the following form. What are the chances to recall? And please give a percentage between 0 and 100. And finally, participants' memory is tested by a queued recall test. There are various conditions that I, of course, cannot present you in a very small amount of time that is left. There is a contrast between self-paced and fixed rate conditions with participants yoked, so that for a participant that decides to take, let's say, 2 minutes for a given pair, there will be a fixed rate participant that will be allowed to use 2 minutes. Judgments of learning are collected according to conditions either immediately after study or sometime after. Paired associates can be presented once or several times, up to 4. And there is a differential incentive condition in which half of items receive a 1-point bonus, half 3 points. Or there is a constant incentive condition where all items are awarded 2 points. Well, the results collected are incompatible with theory 1. First, an inverse relationship between judgments of learnings and study time is obtained both by self-paced and fixed-rate participants. Second, recall performance also decreased in both groups with study time. Remind yourself that the word pairs are of unequal difficulty. So this also explains why, partly explains these results. Judgments of learnings are not about the same for easy and difficult items in self-paced participants. Well, this is very interesting because if they had tried to reduce the discrepancy with a stored norm of study, the judgments should be about the same because they would simply, the self-paced people should adjust their effort to the difficulty of the items. And there should be not that much of a difference between the easy ones that have been briefly studied and the longer one, the difficult ones which have taken more time. So from this, it suggests that judgments of learning are indeed based on study time rather than on perceived discrepancy from a stored norm. Now it's very interesting to see what people do with incentives. They allocate more or less effort to learning as a function of incentives, and this modulates their performance. But their judgments of learning are only proportionally increased by their added effort. So you have here the graph for the study time versus judgment of learning. And you see that the two results for 1 point incentive or 3 point incentive are exactly parallel or nearly exactly parallel, which means that in spite of the diversity in reward, participants continue to be more confident in their learning in the trials that required the least amount of time to complete within a given reward category. Here is the little study one. You see the study one restricted here is really much more promising for the participants than the study times that were much longer. And this is also true for 3 points or 1 point incentives. So the relative calibration of confidence is unaffected by the level of effort involved. So there is a negative impact of learning duration, and because this is shown by the very this vignette here is really bothering me. You see that in both cases, of course, there is a negative impact of study time, but there is also an added value of reward. The two dimensions combine, but what is important is that they don't merge. That is, there is still room for a feeling of confidence that is well calibrated with respect to the various attempts that have been made. And I think that more generally, it's very important to see that in metacognition, evaluations are not completely confused by incentive issues. Incentive plays a role in augmenting effort, but it doesn't play a role in evaluating the kind of confidence one has in one's results. So now it's time for conclusion. There is a double rule for control, the authors say, and I think this is a quite important distinction that several of you have already mentioned in your various papers. First, control helps select the way something is executed. That was exactly the words used by Guido a little while ago. That is, control determines how fast the hiker runs away. The brain similarly selects a level of effort as a function of expected rewards and risks, but that's objective effort. That's what the brain does. But there is another dimension in control, which is the subjective experience of effort, perceived efforts. And this is what the authors call control monitoring. How well the hiker thinks he is doing, how well the thinker thinks he is doing, or the learner thinks he is learning. And here, perceived effort negatively impacts feelings of confidence. Finally, control monitoring tends to be accurate. It tends to predict accurately performance. So now how to reconcile theories 1 and theory 2. Well, there is one thing that theory 2 admits to be true in theory 1. It is that the function of metacognitive feelings is to guide goal-oriented control. So this remains a true feature of metacognitive feelings. But what theory 2 adds is that the basis of metacognitive feelings, that is their informational source, consists in non-analytic heuristics that operate unconsciously and that are not linked to the return of the operation, of the performance, sorry, but it's a self-reflective, it's based on a self-reflective inspection of its own operation. That is, for example, the brain knows that a lot of effort has been allocated to this particular task. And the system uses the ensuing information as a basis for metacognitive judgments that are conscious. As we saw, they are on the right-hand side part of the comparator, and therefore they are conscious. So the big news that this paper brings to us is that even those noetic feelings that have been classically identified as regulating our cognitive actions, they are mainly based on control and not on the activity in its particular content details. For example, processing fluency, which is constantly used as an explanation of noetic feelings, processing fluency is a dimension of control operations, such as trying to remember, trying to perceive, with absolutely no consideration for contents. And actually, that's also what we see in the brain, on the brain of rats or the brain of monkeys that are studied for their metacognitive capacities. There is no content at all that is being used for predicting success and making a decision for, yes, I perceived, or yes, I can remember. So to understand what is the basis of a feeling, of a metacognitive feeling, just see what you do when you want to determine the weight of an object. Of course, you can use a scale, but it's more easy and immediate to lift it. And from sensed effort, you conclude that the object has such and such weight property. So similarly, determining whether one knows a name by attempting to retrieve it, that is forming a feeling of knowing, is just engaging in the process of trying to remember. It doesn't at all rely on a representation of your own ability to remember. It's just doing the thing and having a feeling that tells you predictively whether or not you can actually engage in trying to remember, because it's likely that you will succeed. Hence, concepts are not required to guide cognitive evaluations, form judgments of confidence, even though, of course, they can guide your cognitive evaluations. And even they are absolutely mandatory if you engage in really strategic thinking. But I think that it's opened us new avenues to understand the evolution of metacognition, to see that concepts being not required, monkeys, rats, and many other species are also able to evaluate what they can do and what, whether, for example, they can perceive or remember something accurately. And they do so with exactly the same kind of accuracy than we do when you compare their predictions with their performance. Thank you for your attention.